Okay, so the map that you guys had today for your structure project had a bunch of sort of curved lines all over it, and those lines are called contour lines. Contour lines, and contour lines connect points of equal elevation. They connect points of equal elevation. So one way to think about it is to think about, let's do this. Let's have a side view, right, of an island. Kind of, there's the water, there's a little tree, right? And it kind of is relatively steep on this side, and then there's this long slope over on this side. So it's sort of kind of seeing it from the side. And if you saw it from the top, if you're looking down on it, right, what you'd see maybe is something that looks kind of like this. Where this is water out here, right, and here's the top of our tree. So in this case, we're looking at it from the side, and on this case, we're looking at it down from space, right? See that? So this is the beach around the outside, just like the beach is right there. All right, so what we're going to do is we're going to show on this two-dimensional map, we're going to show the third dimension. We're going to show what we see when we look at this thing from the side. And the way you do that is you use what are called contour lines. So this line right here, which I drew, which is sea level, is 0 feet. By definition, sea level is 0 feet, right? And on this one, that the place where the water, which is 0 feet above sea level, meets the island, forms this shape, right? This is the ring of the island. This is the shape of the island. Now, what happens if we were to raise sea level by 10 feet? Well, if we were to raise sea level by 10 feet, I'll just draw a dashed line across like this, right? So now that's 10 feet above sea level. 10 feet. Where would this new beach be, right? Well, it would be something we can kind of drop this straight down over here. So it would be, we're going to drop that straight down. Be somewhere like, drop this one straight down. Be something like this, right? So this is 0 feet. This is 10 feet above sea level. If we raise it another 10 feet, sea level another 10 feet, where does the beach occur, right? Well, it occurs just in this little ring right here, which would be sort of like that. And then finally, if we do it one last time, we catch just the very top of this thing. That's 30 feet. We get just a little tiny circle like that. So I'll label these, right? So this is 0 feet above sea level. This is 10 feet above sea level. This is 20, and then the one in there is 30 feet above sea level on the inside. See how that works? So each of these lines that we created here, each one of those is a contour line. It's connecting points at equal elevation. If you were to walk along the beach all the way around the island, you're staying at sea level, you're neither going uphill nor downhill. You're staying at the same elevation. So that is a contour line connecting points of 0 feet above sea level. If you were to walk along this line right here around the island, you'd neither be going uphill nor downhill. You'd be walking horizontally, and you'd be staying at 10 feet above sea level, and then 20 feet and 30 feet. Okay? So the map that you have in the classroom is one of these. It's called a contour map or a topographic map because it shows you the topography, the ups and downs. Right? So it has lines maybe that, I don't know, we'll just kind of pick some. You know, this is north. It's got lines that are kind of running like this and then maybe over here like this. So let's say that this is the only contour line on this map. Put this under here a little bit more. Let's say this is a map, and this is a contour line, this squiggly line here and over here. Is it possible that you could be walking along, let's say it's 10 feet above sea level, who knows what. You're walking along a map at 10 feet above sea level, and then all of a sudden it stops. There is nowhere to go that is 10 feet above sea level. Is that possible? No, that's not possible. As you can see up here, contour lines are always closed. They always come back and start. Now, they may be very irregular, but they're always going to come back and connect with themselves. So what happens here? What do we do with this? Well, who knows? But it maybe goes out here like this and comes back. And likewise over here, who knows where it goes, but eventually it's going to come back. So these are all 10 feet above sea level, and that would be the shape maybe of the contours. All right? Now, if you had, what if you had something that looked like this? What if you had something that looked like this? I'm putting in the elevation. So this is north. We're looking down from space here. So what you have is you're looking down from space and you have 5 different contour lines. Each contour line connects points of equal elevation. So this, everywhere along this line is 10 feet above sea level. Everywhere here is 20 feet, 30 feet, 40 feet, 50 feet. And you want to know what that looks like, not just from looking down on it, but what if you were standing over here and you were looking sideways at it? What would that look like? Well, that involves taking a topo map and converting it into a topographic profile. A topographic profile, which means instead of looking down, you're going to see what you would see from the side. And this is perfectly analogous to what we did over here. In this case, we took a topographic profile and we made a topographic map out of it. Now, I'm going to teach you how to take a topographic map and turn it into a topographic profile. So how would you do that? Well, the way you do it is you need another piece of paper. Right? So we're going to set up something down here like this, right? And I'm going to draw, what is our lowest elevation? 0. So let's make this, excuse me, the lowest is 10. So let's make this 0, 10, 20, 30, 40, 50, 60, right? So those are the, and we're going to kind of draw lines across really, really gently, demarcating each one of those different elevations. So remember, on this plot, going up, since we're looking down from space, that's north. On this plot, when you go up, that's up. This is literally up, and this is down. Okay? So we're looking at it as if we were standing over here on the side and looking sideways at whatever is here. So this is what you do. Set this thing up. This is the same width as this, right? The elevation range that I have over here, this is, say, feet above sea level. Feet above sea level over here. This is the same as the elevation range that we have over here. And let's say that we want to do it from this point, we'll call it A, to this point over here, which we'll call A prime. Oop, my computer slipped a little bit. It's not doing any good. I need a rock. The geologists don't have a rock. Here we go. What's that? A little hard. That's too smooth. I need a book. Hold on, hold on. All right, forget it. I'll just do it on my own. Okay. So what you do is you take a piece of paper and you lay it down and you line it up so that it's going between the 2 points that you're interested in. So from A to A prime, I'm going to put this on here. Put a tick mark here, label that A. Put a tick mark here at the top of the page and call it A prime. See how it's at the top of the page? Then I'm going to put a tick mark on the page everywhere that one of these contour lines crosses or intersects my page. And then I'm going to write down the elevation of each one of those numbers, right? So the first one was 10 feet above sea level. The next one was 20. I'll just lift it up and look underneath. 30, 40, and 50. Okay, so I can take this piece of paper now. Get this out of the way. And I'm going to move it down here. And this side, this y-axis is A, and this other side, this other y-axis is A prime. So what I do is I line the tick mark that I made for A. I align that with the appropriate axis, right? And then what I'm going to do is I'm going to slide this page up and down, always keeping the A tick mark over on this A axis. And how far am I going to slide it up? I'm going to slide it up until I reach the elevation of the first tick mark. So the first tick mark says 10 feet. So I'm going to slide this up until I get to 10 feet. And I'm going to go across the 10-foot line. I'm going to put a dot. The next one's 20 feet. So I'm going to slide it up, keeping this tick mark for A on the y-axis. Slide it up and put a tick mark there for 20 feet. Slide it up and put a tick mark for 30, and for 40, and for 50. And I get a series of dots that look like this. So then I connect them in a nice kind of organic looking way. Who knows? And this is the land surface. This is what I would see if I were looking from the side. Now, obviously, I've got to go through and erase all these horizontal lines that I put on there, but that's the basic idea. This topographic map, which has a hill sloping down from A to A prime from roughly 50-something feet to below 10 feet, is what we see here. A hill that starts up in 50-something feet and slopes down to below 10 feet over here. You see how that works? So what you're going to be doing tomorrow is you've got this geologic map, right? Hold on. What you're doing is you're creating a geologic map, which you started today. And it's got, what's it have? It's got some big blob of granite over here, right? And it's got all these, I don't know, these layers of rocks that are cutting across like this, whatever. Maybe it's got some basalt cutting through, right? But then you've also got these lines on here that are the topographic lines. And I don't know what they look like. You know, who knows? Something like this. Who knows? So like 10 feet, 20 feet, 30 feet, 40 feet, whatever, above sea level. So what you're going to need to do is you need to create a, let's say it goes from A to A prime. You need to create a topographic profile, right? And then what you're going to do, and this takes a little bit more work, and we'll work on this in class, is you need to then fill in what's going on in the subsurface. You know, are the beds dipping this way? You know, is this one bed, and this is another bed here, and this is another bed here. Who knows what's going on? Whatever the geology is, you're going to have to figure that out. And remember, this is where a tree would go, right? So you're looking at it horizontally. So you've got the shape of the land surface from these green topographic or contour lines, and you have the the orientation of the beds from the geology that you filled in. But how do you know how they're dipping? How do you know what's going on there? Well, the way you know how they're dipping is because you have strike and dip symbols on the map, whatever those are. And so you're going to use those to figure out what's going on in the subsurface. Okay? So with that in mind, I'm going to give you a break, and then when we come back in a minute, I'll do a short video where we kind of put all this together.